Today we're going to continue on with 4.1 and do one small thing that's different from yesterday. So you'll recall yesterday we found general solutions for all of the problems. Those involved a plus c, and it represented an infinite number of possible functions that when you took the derivative you would get the starting derivative. Get the starting function. What we're going to do today is we're going to then take it a step further and find the one particular solution. Okay. So instead of getting a family of solutions with a plus c, you'll get one solution, no plus c. And that's going to cause some problems for some people. All right, let's start with this. Take that function, 1 over x squared, and find the general solution. In other words, take the antiderivative of that. Don't get caught up on the terminology. Okay, it doesn't matter what I call the function. If I'm taking capital F prime and I take the antiderivative, what function will I end up with? Capital F, correct. Okay, good. So the name is irrelevant. And when you get done with that antiderivative, you should have a plus c. Quick question for you. What's negative 2 plus 1? Negative 1, not negative 3. Okay. Now, we're going to throw another twist into this. So you've done the general solution, which we'll get to in a second. But now I'm giving you some initial conditions. Now that you have that general solution, I'm also telling you that f of 1 equals 0. That information is going to allow me to get rid of the c term and put in a particular answer there. So you hopefully got this as the general solution with the plus c. So what does f of 1 equals 0 tell me, and or how can I use it to get rid of the c?
You can just solve it like an equation. You can put what you plug in there, which is 1, into x, and then set it equal to 0.
And then solve for c, correct. Okay. So this is telling me that when x is equal to 1, the whole function equals 0. It won't always be 0, it'll be something different. But in this particular case, you're going to put 1 in for x, put 0 in for f of x, and solve for c. And you get something like this. C equals 1, so your final function is then that guy. Okay. So again, we go from a family of solutions to a particular solution based on that given information, or the initial conditions, I should say. If you don't have the initial conditions, you can't solve for a particular solution. You just get a general solution. This process of going from the initial function to the particular solution is what's called a differential equation. You saw me use differential equations in the slides yesterday. That's the process that you go through. Take a general equation, take the antiderivative, solve for c, plug it back in. That ending equation that you get is called a differential equation. Clear? All right, then try that one. We'll start easy. comes from the possibility, the idea that when you take the antiderivative, you can get a whole bunch of different solutions. So if I have a function like 3x squared, the question is what function, when I take the derivative of it, will give me 3x squared, so it's x cubed. But what if it's x cubed plus 7? Well, 7 disappears, so it's what creates an infinite number of solutions, called a family of solutions. And so what we're doing with the differential equations is we're getting rid of an infinite number of solutions and narrowing it down to one.
Oh, yeah.
Was it like, yeah, sorry. You had that one escaped. Yeah. Okay, I'm just.
Thank you. Pass my pen back here. Good job, Matt. Okay, so you'll know, question?
Not about this.
All right, then let me finish this. So he started by taking the antiderivative. My only criticism, and it's minor, Matt, would be that I would show something like this in the beginning. Okay, just so I know where this came from. So I know that that's an antiderivative. Okay, took the antiderivative of each of those parts. Notice the thing that's causing some problems for people is taking the antiderivative of a constant. You just stick an x on the end of it, and then a plus c. This is my general solution or my family of solutions. I don't want that. I want to use this information to find the particular solution. So he plugged 1 in for x and set the function equal to 5, because we know that when x equals 1, then the function has to equal 5. And then solving for that, I'm not really sure what that says right there.
That was the 2 messed up, so then I tried to just cross it out and go to the next, and then it messed
So
up.
they should just be crossed out.
Yeah, it's crossed.
Okay, that's just a mess.
Yeah.
Okay.
Oh.
I think my battery's dying.
No, at the end.
What's the matter? We're good. So he solved for c, and then the final answer to the question, is this function over here, when he narrows it down to the particular solution. Okay, so there's only one equation or function that will satisfy those conditions. Okay, well done. Any problems with that? Okay, again, it's just taking the antiderivative from yesterday, but there's an extra step of solving for x. Okay, let's try this one then. Notice this one ramps up a little bit. I gave you the second derivative. I want you to find the original function. So you got to do it twice, because you have 2 chunks of given information here. No, don't do that. That's something completely different. No?
No.
Why was I thinking? Huh? So why am I saying things about broke them? Yeah. I don't know. Hopefully. Like.
That's okay.
No, sine taken negative. Oh. Because it's the opposite of.
That was easy.
Like I made 3 guesses. Like I just pretended. Which I don't know if that's something you're allowed to do. But it's
Oh, this one? We'll push you guys to the end. Till we run out of people. Anybody making any progress?
Oh, that would be good, that would be good one. No, this is-
No, we're doing an antiderivative now.
I think I'm doing a lot of things wrong. The first one when I
And you use that information to get rid of the C. Plug in 0 for x, set it equal to 2 and solve. Alright.
It's too late now.
I know, but that was like,
You're doing great. Proud of you.
so, could I be right? Wait, would you perceive that I did? Did you get this number from the books? Okay, so I get a figure, so what I did, like when you plugged in the one was, or when you plugged in like, for the C of F5, where you're like F5, and I was like, what is the second, there is
Yeah.
Surprisingly enough, that's the biggest number. I blame the algebra teachers.
Or no, cosine is 0, 0. Sine is
Cosine of 0 is 1.
0 plus.
They didn't like me at all.
I died. I know.
They wouldn't, I know, I can see that too. But like because of that, I didn't like try to help them.
She's starting out big. What?
That's too big.
No, you're great. You're fine.
Have you ever had Taco Bell?
How was that?
Is there a eraser?
As opposed to not.
Oh, yeah.
You're big on
Oh, at the end.
There are drinks if you can wait.
Wait, so we can just go get them or no?
I understand. Got a big sugar one.
It's got a big basketball game tonight.
It's a wide scale.
Oh, it's urban legend.
But if you think you're on a sugar high, talk to someone.
Why not? Is it like
The opposite is true. Like I don't know how to put it in place, so it's really kind of bulky, but it's not really affecting me that much. I'm trying. He's the worst. He's good.
I only have tea with except
Some honey in it.
like green tea with honey.
Half and half. I'm on doing water.
Well, yeah, but most of us are.
Oh, I think you're gonna tell me something else.
You can pretty much have anything and get anything. Everything in variation is okay.
Yeah, it's from like drinking
If Diet Mountain cause lupus, they take it. Right, right. Okay, Jenny McCarthy. Right.
You're freaking out, you're good. No, I'm not freaking out.
And you know, if you wave your arm in the air like this, you'll get cancer.
No.
And you know, if your hand is bigger than your face, you'll get cancer.
Yeah.
his name's Dave and he only drinks diet.
I mean, his mom has so much diet coke. She's so much.
It does do all kinds of bad things to you, but lupus is not.
Hey, gone. You should call one of those, cell phone users.
Not now. All right, hold on, before you sit down. Don't look at me in that tone of voice.
She did it.
Hey, I know she did a great job. Explain to the uneducated how you did that.
Okay, so first I found the antiderivative of f double prime of x, and I got that. And then I plugged in 0 for x, and then set the whole thing equal to 2, and solved for c. And then I substituted 5 for c in the f prime of x. And then I found the antiderivative of f prime of x, and then I plugged in pi over 2 for x, and then I set that equal to negative pi, solved for c, and then plugged in negative pi over 2 for c.
Your method is solid, but your c term, I think, at the end is wrong. I think it should be 3 minus 7 pi over 2.
Yep.
So let's see where you, here, I'll do it, you can sit down. You're already Okay, couple things. Just because we're starting early, I want to make sure that the notation is correct. So you actually did the antiderivative of fx, which give us f prime, and then that's an f prime. I see the prime there. Okay, so when you got down to this step, we're rock solid. Sine of pi over 2 is 1, so that becomes negative 3. That's 0. That's 5 pi over 2. So we get an equation that says negative pi is equal to negative 3 plus 5 pi over 2 plus c. Right?
Yeah.
Move the 5 pi to the other side, so negative pi minus 5 pi over 2 is negative 2 pi over 2 minus 5 pi over 2 is negative 7 pi over 2. And adding 3 to both sides, we get that. So then this would be what goes in down here. Instead of that. Now, when we're doing a multi-step differential equation like this, if you look in the book, they do a couple things, like they change the second constant of integration to a d, just so you don't get the two things confused. You'll also see some things will do this and incorporate a c sub 1 and then a c sub 2 to make a difference between the two constants of integration. It doesn't really matter, it's still the same thing. Yes?
Do you care if for the C put it as a decimal or do you?
No, always exact, always fraction, don't,
Okay.
yeah, don't use a decimal.
Okay. Just
Okay.
asking.
All right, good. Any questions on that? All right, so that's about as bad as it gets. And there I incorporated a double differential equation along with some trig just to keep you on your toes. You're welcome. And I think we're about done here. Oh, one little thing. We're going to talk about slope fields in the future, but I wanted to show you where slope fields come from. So here I have 3 of the possible families of a solution. And if we stack all those families, the infinite number, it would just fill the screen. But what they commonly do is create something called a slope field. And a slope field are little tangent lines next to the graph all the way along the graph. And if you do it for all possible solutions, you end up with something called a slope field. And we'll get to that later. We'll do some work with slope fields. But I wanted to, the reason I incorporated here is because those come about from the family of possible solutions for each one of these indefinite integrals. Okay, we're done. I've seen a lot of this lately, so I thought I'd throw that up there just to let you know that a kitten dies every time you do that.
Go back.
2,
The one slide. I saw the puppy one.
Yeah, I remember that.
there's a
Right
puppy
in
one
here.
too, yeah.
Birthday, yeah, I remember that one.
That's when you factor wrong, I think. There's a bunny one too.
Oh, I haven't seen that.
I'll fire up the bunny one.
Yeah.
Are we allowed to get drinks
What's
now?
that one for?
Yeah.